Okay, today's lesson is 3.2a, Logarithmic Functions, and we are going to be concentrating this first part on evaluating expressions involving logs. So what is a log? Hopefully you learned something about this last year. In 1.7, we talked about inverse functions, and how do you find inverse functions is by switching the x and the y, which is why they were symmetric to the line y equals x. Well, if we take our log function, if we take our exponential function that looks like that, okay, and I need to solve for that variable, we don't really have a way to do that, except we now know we can find the inverse, and if I find the inverse, I switch the x and the y. Well, now they define that function as a log or logarithm. Okay, so if you notice, I kind of color-coded it to make it easier, but the b in my logarithmic function is the same as my b in my exponential function. The variable up here, y, the exponent, is the same thing as the log. So the log is just a fancy way of saying what's the exponent when you have a base of this number. What is it? When I write x with a base of b, what's the exponent? That's what it's saying, okay? But I want to touch back on this graph real quick. This was our exponential function that we talked about in the last section. It never goes below the x-axis. So when you get the inverse and it looks like this, it's never going to go to the left of the y-axis, which means our domain is from 0 to infinity. Like our range was 0 to infinity. Our range here, our range was our domain here, our domain, negative infinity to positive infinity. My range, negative infinity to positive infinity. So the range of 1, you'll see when we go through it again. But more importantly, I want you to remember this picture, and remember that you never see the graph over here on the left side, the parent function that looks like that. And that should help you remember that you cannot ever take the log of a negative number. It's a really important concept that you want to remember. Okay, so let's go do some examples. Now, several years ago, or many, however you wish to look at that, I taught out of a different book, and they called the person that authored the book, called these problems White House problems. Because what color is a White House? Well, I hope everybody knows a White House is white. So that being said, that's what these problems are like. And I'm going to do it a short way. If you want to know the long way, you're welcome to email me or come see me, and I'll be happy to show you the long way. Both of them involve a step that's exactly the same, but it's just shorter, and people see it better, and I think there's a better relationship between it. So I'm going to carry forward. So this first one, we have the log base 8 of 512. And as I said, when you're trying to find it, the log, when it asks you for the log, it's saying, what is the exponent when I write 8 when I write 512 with a base of 8? So you go in your calculator and you go 8 times 8 is 64, and 64 times 8 is 512. So 512 is 8 to the third power. Well, when you have the log base 8 of 8 to the third, the answer is, this is where what colors the White House comes in. What color is the White House? It's white. What is the log base 8 of 8 to the third? It's 3, because it's right there. The answer is right there in front of you once you rewrite the expression to be. And this is because we're kind of composing inverse functions. So when you look at this, log base 4 of 4 to the 3.2, what color is your White House? Well, it's the odd man out, so it's 3.2. Okay? You're always, as long as these two numbers are the same base, okay, as I did right here, and you have it right here, then whatever number is left is going to be the answer to your problem. Okay? Look at log base 2 of 1 over 32. So I've got to figure out how to write 32 as a base of 2. Okay? So when you put it in a calculator, 2 times 2 times 2, if you don't know your powers, well, 2 to the 5th power is 32, but that doesn't say 32. That says 1 over 32. So that's why there's a negative sign in front. So the answer is negative 5. Okay? Look at 1b. I've got 16 and I've got 2, so I'm going to write 16. I need to write both of those as a power of 2. They have to be the same power base. They have to have the same base, or you cannot answer, the answer is not the power. Okay, so that's what's happening. So log base 2, 16 is 2 to the 4th, and the square root of 2 is 2 to the 1/2. So when I simplify this, I'm going to show you, I'll back over here. We just took this number up here, and we just took that number there. But if you think about what's the exponent on the lower base, it's a 1. So that's 3 over 1. And this is negative 5 over 1. Well, this is going to be 1/2 over 4. And when you simplify that, that becomes 1/8. That's your answer. Log base 9 of 81. Well, what is 81 written as a power of 9? It's 9 squared, so my answer is 2. Okay, this one is written a little bit differently, okay, but it's the same concept, y'all. So both of these, however, we all of these that we've written, okay, you have log base 9 of 9 squared is 2. Log base 4 of 4 to the 3.2 is 3.2. Well, if I just reverse it and put the exponent here and raise it such that the log is in the exponent, but these two bases are the same, what am I going to have? Odd man out, so the answer is 1. So if you get this and understand it, I'm telling you, it's a lot faster than putting your calculator. But, all right, so basic properties. One thing that you need to know is if there is no base on it, then it is referred to as a common log, okay? And this is that concept that we were just doing. Log base 10 of 10 to the x is x, or 10 raised to the log base 10 of x is x. So those are inverses, as we've just been saying. They undo each other. It's kind of an important thing. So here are a bunch of common logs. Log base 10 of 10,000. Well, how do I write 10,000 as a base of 10? It's 10 to the 4th. So the answer is 4. Okay. This one, I cannot, says 3b, says log of 0.081. Okay. I cannot write 0.81 as a power of 10. So this is one that you have to use your calculator. You got a log button on your calculator, you just punch it in, and there's your answer. I have a tendency to carry it out 4 places because you know how old I am. But you need to pay attention in delta math, whatever directions he says to round it to. So pay attention to that. Okay. Next, I have the log of -0. Well, first of all, I don't know what -0 is. But more importantly, can I take the log of a negative number, or can I take the log of 0? Okay. And if you remember that graph, it doesn't go to the left of the y-axis. So in delta math, you would put your answer like that, or sometimes you write it as undefined. Okay. 3D says 10 log 3. Well, that log without a base is base 10, so those 10s cancel each other out, and my answer is just going to be 3. Okay. In the last section, we talked about the natural base, the natural base, and the natural base is E. So here are some more common things that you want to know. But basically what you're thinking of, okay, they say it like that, but let me write this for you. It's the log base E of x is the same thing as writing the ln of x. Okay, so when you see this right here, okay, when they say ln of e to the x equals x, that's because you have the log base e of e to the x, and the bases are the same, so it's just going to be that exponent. And that's the reverse of it. But look, we're going to do some examples. These are like the easy ones again. Okay, ln of 32. 32 doesn't have a base of e, so you have to use your calculator. Find that ln button, punch it in, and that's what you get. Okay, e to the ln of 4. That's like this guy right here. They cancel each other out. They undo each other because they're inverses. So my answer is just 4. Okay, ln of 1 over e to the 3rd. You want to think of that as e to the -3. Again, ln and e undo each other, so my answer is just -3. ln of 9, I cannot write that in a base with e, so I have to use my calculator, and when you punch it in, you're going to get 2.1972, and the negative is because the negative's out front. Okay, last 2 problems I'm going to do here are some word problems that go along with what we did in the first section, but the difference is you didn't exactly know how to solve them then because we were looking for a number that's in the exponent, the variables in the exponent. So let's go look at these 2 so you can do your problems, homework. Element X has a radioactive isotope such that every 20 years, well, 20 years is a time issue, its mass decreases by half. Given the initial mass of 770 grams, how long will it be until the mass of the sample reaches 400 grams? Okay, so, and they want that answer to the nearest tenth of a year. Okay, so really what I wanted to point out to y'all here is this is an example of a half-life problem. Okay, half-life or doubling. Okay, or if you have something doubling. Okay, you take that original exponential growth formula that we have, n equals n sub 0, and it was 1 plus r to the t or 1 minus r. So if it is decreases by half, which we talk about or call it half-life, then that's going to be 1/2. If it says if it's doubling, then that number is going to be a 2. Everything else is the same. So I'm going to plug in the amounts. 400 is what I want to get to, so that's the final amount. 770 is what I started with. Okay, now this is a key about this problem. I have a t on here, and you're going, where does the 20 years? Well, the key is that every 20 years, it decreases in half. So the half-life is 20 years. Well, I need to know how many 20 years there are in that time. So when you do a problem like this, you actually have to divide by 20. So the first thing you do to solve that, y'all, when we are looking to solve for the variable in the exponent, is we have to isolate the expression that has the exponent. So I'm going to divide by 770. And when I do, I'm going to get that lovely decimal. Okay, now I have the variable in the exponent. And how do I get the variable out of the exponent? I undo this exponential function, and I'm going to undo it with the log. So I'm going to take the natural log. You can take the natural log. You can take the log. It does not matter. Okay, but one thing you do need to remember from last year, and we'll talk about it again some more, but for these problems, we had the power rule with logs, and that means you get to move this down front. Oh, Pooh Bear. I didn't mean to do that. I know what happened. Anyway, you got to move this guy down front. Neat. Okay. You move it down front so it looks like this. So I got to go up because I'm running out of room. So when you do, ln of 0.51948 equals t over 20 times the ln of 1/2. Okay. Now I'm solving for t. So I'm going to divide both sides by ln of 1/2. And I'm still trying to solve for t. So I'm going to multiply by 20. And so it's going to look like this. And that's exactly what you want to put in your calculator. And when you do, you get a nice decimal. The directions say round to the nearest tenth of a year. So I'm going to have 18.9 years. Okay, last problem. Ella is going to invest $18,000 and leave it in account for 8 years. So she's going to invest $18,000. That's the initial amount. And I always use blue. And leave it in account for 8 years. That's my time. Assuming the interest is compounded continuously. So continuously, money, interest means that we are talking about our PERT formula. Okay, we're looking for the interest rate, and they want us to round that to the nearest hundredth. What would be required in order for Ella to end up with 22,000? So I've color coded 22,000 is our final amount. So I'm going to plug those in. Okay, and again, I have a variable in the exponent. So first thing I'm going to do is get rid of the 18,000. So when I divide both sides by 18,000, I get this lovely 1.222 repeating. And again, I just have a tendency to carry it out 4 places. Equals e to the 8r. Okay. Now, just like I did up here, y'all. Okay. This one, I told you could take the log or the ln. This is why I always use ln. Because on this one down here, you all absolutely want to use ln because it makes your life easier. Because if I use ln on both sides, then ln of e to the 8r is going to be equal to 8r. So that makes the simplification much easier. Now all I have to do is divide by 8, and then I'm going to punch that in and get that lovely decimal. And it said round to the nearest hundredth of a percent. So I actually have to move that over 2 places to get 2.51%. And that is logarithms. I love logs. I hope y'all do too. Please don't hesitate to email us or come see us if you have any questions. Thank you so much for watching. Bye.